Here we have our defined cam part with added face milling and profile operations from the previous Jumpstart videos. For the third operation, we're going to use InventorCAM's pocket technology to perform the machining of the pocket. From the InventorCAM Manager, right-click the Operations header and choose Pocket from the Add Milling Operations submenu. When the Pocket Operation dialog box appears, we'll again see that the workflow of setting up our current operation is very similar to the previous ones. Once again, click the New button to start the geometry definition. You'll notice that the geometry selection process is very similar to Profile. In the Graphics window, you'll want to pick on a single edge of the pocket and then select Auto Constant Z to close the chain. Finally, click Yes to accept the selection. Our toolpath will work inside this geometry. Click Finish to confirm the geometry definition and display the operation dialog box. Next, we need to select a tool. So switch to the Tool page and then click Select to display the Part Tool table. Rather than add another tool, let's use the previously created one by simply choosing it from the list. After we select the 6mm end mill, which is listed as tool number 2, we can click Select to choose the tool for the operation and exit the Part Tool table. Next, we'll move on down to the Levels page to define the milling levels. Let's click Upper Level, and then pick on the top face of our target model in the Graphics window. Click OK to accept. We are only machining one pocket in this example, so we're going to leave the depth set to constant. In the instance you had multiple pockets with varying depths, you can use the variable depth option to machine those pockets with a single operation. Next, we have to click the Pocket Depth button and then pick on the lower face of the pocket. Click OK to accept the selection. The step-down parameter is set to 3mm, which is half the tool diameter. InventorCAM automatically defaults to this value. But because our pocket depth is roughly 8mm, let's enable the equal step-down option to keep an equal distance between all Z levels. Like in Profile, you'll notice that the step-down parameter has changed to max step-down. Moving to the Technology page, you'll see that we have several options for our toolpath. They are Hatch, Contour, Hatch plus Finish, or Plunging Pattern. By clicking one of these options, we get a visual representation of the toolpath strategy in the lower left corner of the operation dialog box. Take note that when choosing a strategy, a separate tab is displayed with the parameters that are specific to that strategy's functions. For this example, we will leave it set to the default option of Contour. Switching to the Contour tab, the tool should start from the inside. Select Fillet for the type of corner we want the toolpath to make, and we can simply just use the radius values that are calculated by InventorCAM. And, of course, we want to be climb cutting. For the adjacent passes connection, change the selection from linear to smooth. This will position the tool tangentially as it moves from one pass to the next. Okay, next we need to switch back to the Technology tab. As we see in the minimum overlap area, our 6mm tool will overlap 50% of the tool diameter with each step over. Over in the Offsets area, we have the option of leaving extra material on the wall, island, and floor in the instance we were only using this operation for roughing. We can also choose to do a finish pass on the wall, the floor, or both. For this example, let's enable both checkboxes and then enter a wall and floor offset of 0.24mm. The roughing will take place up to the specified offsets, and then the tool will make the appropriate finish passes to remove the excess material. But before we move on, let's make one more change. Instead of having the tool perform the wall finish with each step down, let's make it perform a single finish pass after the total depth is reached. To do that, simply set the depth option to total depth in the wall finish section. Last on the tree is the link page. In the ramping area, we have several different options for how we'd like our tool to enter into the pocket. Let's choose Helical from the drop-down list. With this option, the tool will enter the material in a spiral movement according to two things: the defined angle and radius. If using a tool without center cutting capabilities, then the tool step-down parameter would also be taken into account. If you click the Points button, the Ramping Points dialog box appears and shows us the ramping position and the related chains. For this example, we'll just use the default entries and click OK. Now, since we've chosen to perform a finish pass, we can specify how we'd like the tool to lead in and lead out of the cut. Like we've done in the previous profile operation, let's use the option of arc for the lead in with a radius value of 4 millimeters. Have the lead out do the same by enabling the Same As Lead In checkbox. We can now click Save and Calculate to add this pocket operation to the CAM tree and calculate the toolpath. Then, select Simulate so we can take a look at the wireframe toolpath. After clicking Play, we should see the tool make a helical entry into the pocket. The toolpath that is green in color shows us those tool link movements. The tool then clears the pocket in 3 equal step-downs using a contour strategy. For the finish pass along the wall, we can see the lead in and then the lead out. And finally, we can see that there's a finish pass on the floor. This is exactly what we want to see. Now that the simulation has come to an end, let's exit the control panel and the pocket operation dialog box. Next up, we'll add a drilling operation to machine the holes through our CAM part. This will be the last operation that we need to define in order to complete the part programming.